Hello everybody, and welcome back. We're looking at our very third question on the 2008 Manitoba Math Competition. Question 3 is broken up into two parts. Part A, find an equation of the circle passing through the origin and the points with coordinates 10, 0, and 0, 8. So we could draw a very quick picture here. So we have 10, 0, so that'd be over here. And 0, 8, that'll be up here. And we also pass through the origin. And so let's just draw sort of what our circle might look like. Yeah, that's a fine circle, I guess. Maybe we can make it a little rounder there. But the circle passes through here. Now, what are we to do? Well, 3 points is enough to determine the equation of a circle. And I think there's lots of different ways we could go about doing it. For example, we have a right-angled triangle here. And a right-angled triangle inscribed in a circle means that the hypotenuse is going to have to be the diameter. So the midpoint of the line here is going to have to be the center of our circle. So we could say something like, well, it's going to have to be at 5, 4. Now we know the center, we can figure out the radius as well, and we could get the answer that way. Another thing we could do is realize, hey, these two red lines here, they form chords. Now, what happens when I take the center of a circle, something I'd like to find in this case, we need the center of the circle and the radius to get the equation. What happens when I take the chord, drop a radius through it? If the radius hits at a right angle, it splits the chord in half. Well, I know one of these chords has length 10, the other one has length 8, so I know what it looks like when they're split in half. And right angles, well, hey, this is the x-axis, so a right angle to it is just the equation x equals something. What does x equal? Well, it splits it in half, so x is equal to 5, and this one over here becomes y equals 4, and they intersect exactly at the center, so once again, we see the center is 5, 4. And I'm sure there are a bunch of other ways we can work this out, but the center is at 5, 4. So my equation so far looks like you take the x-coordinate, the difference there, difference in the y-coordinates, square them, and you should get the radius squared. Now, I don't know what the radius is, and we could work it out. You know, this isn't that hard to see. Radius, oh, it's a 4 and a 5. We can figure out it's a square root of 4 squared plus 5 squared. Or we could just substitute a point in. Sub in 0, 8, sub in 10, 0, sub in 0, 0. Whatever value you get will be the r squared value. So I could sub in a point like 0, 0, 0 here. And so 5 squared plus 4 squared is equal to r squared. Well, that's 25 plus 16 is equal to r squared. 41 is equal to r squared. So the equation that we're looking for, because they said we want the equation of the circle, it's x minus 5 squared plus y minus 4 squared is equal to 41. The radius is going to be root 41. And you can double check this by plugging in any of the other points that they gave you, the 0, 8 or the 10, 0. It's all going to work out. So we get the equation of the circle. Very nice. So what did B part say? Find an equation of the line tangent to the circle, and now we're given a different circle, with equation x minus 2 squared plus y plus 1 squared equals 25 at the point with coordinates 5, 3. All right. Let's draw ourselves another picture. I know that it's y minus 2 squared. No, sorry, x minus 2, then y plus 1 squared. Y plus 1 squared is 25. Incidentally, this tells me it's got a radius of 5. And so it's centered at 2, negative 1. And we've got, they want 5, 3 here. And that's not on the circle, is it? Find an equation of the line to, okay, tangent 2. That's fine. Okay, so 2 and negative 1 is down about here. And I want the tangent line. So it just comes in, touches, and keeps going. Now, I've got a circle, I've got a tangent line. What do I always recommend we do? Connect up the radius, and the radius hits the tangent at a right angle. Now, the radius is 5, but that's not really what we care about. We want the equation of the tangent line. So we're looking for something like y equals mx plus b, or point slope form of the line. Heck, we've got a point on here. If we knew the slope of the tangent line, we'd be all set. How could we ever figure out the slope of the tangent line? Well, if we knew the slope of this radial line, if we called that, say, m, the slope of the tangent would be negative 1 over m, negative reciprocals. This is a nice relationship between slopes of perpendicular lines. Okay, well, you've traded one slope for another slope. How can I get the slope of m? I have 2 points on this line. So, slope of the tangent is going to be negative 1 over m, which is rise over run. So that's going to be negative 1 over 4 over 3, or negative 3/4. So we'll get y equals mx plus b. That's a fine way to do it. You could do point slope form of the line. I'm sure they'd accept them all. And plug in some points here. So 5 for our x, 3 for our y, and we'll get 3 is negative 15 over 4 plus b. Well, 3 is really just 12 over 4. And from there we can get b is 27 over 4. So the equation of our line is going to be y equals negative 3/4 x plus 27 over 4. All right, so there we go. Not a whole lot else to that question, but as long as you drew the picture and connected with radius to the tangent, you'd be completely fine there. All right. So that's what did I say that was? That was question 3. So in the next video, we're going to take a look at question number 4. Hope to see you there.